Salam and greetings. My name is Muhammad Aiman bin Muhammad Ruslan, matrix number KIB1004. Today we'll be conducting a lab test for AC power supply. For question 1, we'll be conducting a full wave rectifier circuit. So first we will construct the circuit itself. The circuit consists of an AC source, an ideal transformer, four practical silicon diodes labeled 1N4002, a load resistor, and a capacitor. Now first for the values, for the AC source, we'll be using a sinusoidal wave, which represents an AC source, but with an amplitude of 2 and a frequency of 50 Hz. For the transformer, we will start with the ratio of 1. So it is neither a step up or step down transformer. And whereas for the diodes, for all 4 diodes, we will be using a practical silicon diodes with label 1N4002. And then for the resistor value we will be using 1K because the end of my matrix number, which is KIB100430, is 0, so we'll be using 1K instead. And for our capacitor, we will start with 47 microfarads. Now we will observe the waveform. If you observe the waveform, you can see that because this is a full because it is a full wave rectifier, you can see that it is quite smooth for voltage output. However, as you can see, there is still a lot of ripple. The ripples are still there. As you can see, there is the V output. It is an okay, but it still has very obvious ripples. So now we can if we increase the value of the capacitor from 47 micro to 2200 microfarads or 2.2 millifarads, we will see that the curve is smoother. Therefore, it produces a smoother VP output. As you can also see, the difference between the V output and the source is very great. Even though because we are not using we are using transformer ratio 1. The voltage drop between the AC source and the V output is because of the diodes. Because the diodes the current goes through 2 voltage diodes. Therefore, the voltage drop is about 1.4 volts. So now we'll be using another transformer ratio. We will use 4 this time. So as you can see, the V output is much higher as compared to before. As you can see, our AC source remains the same with an amplitude of 2 and a frequency of 50 Hz. However, the V output has massively increased compared to previously. However, now using the small capacitor value, again we see that the ripples are very obvious. So if we increase the value of the capacitor, again from 47 microfarad to 2200 microfarad, we can see that the V output will be much smoother and the ripples are flattened. Next, for the second question, we'll be using the same circuit, but this time we will be changing the parameters. For the AC source, we will still be using the same AC source with amplitude of 2, but the transformer ratio will be using transformer ratio 2. For the diodes, we will still be using 1N4002. And for the resistor, we will maintain as 1000 ohm. But for the capacitor, we will change it to 1000 microfarad. So now we are tasked to find V output. First we shall observe the V output within the using the waveform. As you can see here, the red wave indicates the V output. It indicates that it is roughly around 2.5. So now we will do the calculation using the formula given. So first we have the V peak from the source, which is at 2 volts, and then we have the transformer ratio. From there we can calculate the V out using the formula. I have input the formula into the Excel. Where we get 2.6, which is roughly about the same as shown as shown with the waveform. Roughly 2.6. Next, we need to calculate the VDC, which is the same as average output voltage. So using the formula 2 times V peak divided by pi, we get 1.655. And for the VRMS, root mean square, is V peak over square root 2. Again, I've input the formula in Excel and done the related calculations. For the ripple factor, we'll be using the formula on the left, as you can see here. And we get 0.483, which is similar to the given ripple factor of 0.482. Okay, here we have the handwritten calculations. That is all for me. Thank you.